This is a quick look at graphical debugging for BerryBots and a little info on why it's useful. So we're going to take a look at Snail. He's a maze solving ship. So Snail uses a pathfinding algorithm to find his way from the start to the finish. He prints a little about what's going on with that to the output console. So we can take a look at the output console to see his target point is 1175 by 575. Which, if we know the size of the stage, makes sense that that's the center of this zone. He also prints out some information on the grid that he uses. He constructs a grid of points across the stage and then sees which of those points can connect to adjacent points without intersecting walls. So he prints out some high-level data about what he's doing there. If we were actually developing Snail and having a problem or trying to make sure he was doing the right thing, then we might need to print out more detail than that, like the actual location of all these 254 points and the edges connecting them and where he thinks the walls are and the route he's taking or whatever. So you can imagine that that would all become overwhelming pretty quickly and become a pain to parse all that data and construct it in your head. And it's a lot easier if we can just let Snail draw this stuff to the screen, which is what we do by clicking this Enable Graphics checkbox down here. So now when he runs through this stage, he paints the whole grid of points on the stage and edges connecting these points that are valid paths and the path that he's planning to take. The red point is his current point on this grid and the yellow point is the point he's going to. And so now we can see what Snail is thinking in a pretty easily digestible fashion. If we take a look at him on a random maze, this is a little more visually pleasing because it's going to be a different route each time. If he couldn't find a route for some reason, this would give us a little more insight as to what's going on and why he wasn't able to find a path. So that's graphical debugging. We can take a look at the API documentation for details. We add this debug GFX class. We have circle, line, rectangle, and text. Rectangle and line are actually functionally equivalent with just different inputs. And the reason that we have both of them is that converting between these two sets of inputs would be a big pain and would also require some trigonometry, which is pretty slow. Because we're using an OpenGL graphics library, we can actually draw either of these sets of inputs without having to do any trig if we let you pass them that way while we're letting the GPU handle the trig. So we provide both of those. We also have fill color, outline thickness, outline color, and duration on all of these. And those are optional with some sensible defaults. And this enabled function basically just lets you check whether graphical debugging is enabled so that if it isn't, you don't have to spend time calculating all the things you need to calculate to actually draw your graphics. Colors are defined as RGBA, red, green, blue, and alpha is an opacity channel. So 255 is pure solid, 0 is completely transparent, and transparent blue would be something like blue 255, A150. So yeah, if we take a look at Snail's code here, the way that you get this graphics object is in your init function. The last argument now is this graphics object. If you just ignore that, that's fine. Lua is okay with that. So existing ships and stages will still work fine. But if you want to use it, you can take it and save it and then do some of these graphical debugging operations. So he draws his path every tick and he draws the grid once at the start of the match. He draws them for 1,000,000 ticks, so they'll stay there for 1,000,000 ticks, which is hopefully forever on most mazes. And draw path is what actually draws each of the points along the path he's taking and the lines. So yeah, that's graphical debugging in BerryBots. I think it's a super useful feature for bot development. I hope you like it. Thanks.